All right, we are going to move on to car loans. Now, the principles in this section that talk about loans and payments of loans can really be applied to any type of loan, but this section really focuses only on car loans as far as the application of these formulas and these ideas. So, an installment loan is a loan that you pay off with a set time period between each payment. Typically, installment loans are monthly payments, so you're making a payment towards the loan every single month. Car loans are monthly payment loans, installment loans. Home mortgages are installment loans with a monthly payment. Your student loans will eventually become installment loans where you have to pay off a certain amount every month. If you pay the minimum on credit cards, those could be a type of installment loan, but it's always better to pay more than that. But those are different types of installment loans. So the loan payment formula for fixed installment loans. So the regular payment amount required to repay a loan of P dollars paid N times per year over T years at an annual rate R is given by, so the payment is P times R over N divided by 1 minus 1 plus R over N to the negative NT power. And remember, the hard brackets are just another set of parentheses. We have the normal parentheses and then the hard bracket parentheses, just so that we can see that there's multiple sets of parentheses in that denominator. And then this calculator formula is the wrong one. This is actually from the annuities section. I forgot to change it. I copied and pasted. I forgot to change it over. So when we enter this into our calculator, we're going to do P parentheses R division N parentheses division parentheses 1 minus parentheses 1 plus R division N parentheses exponent parentheses negative N times T parentheses parentheses. So to remind ourselves, P is going to be our principal. It's also going to be known as the loan amount. R is the interest rate of our loan. N is the number of payments per year. T is the years of the loan. And those are all of our symbols. PMT is the monthly payment. So this formula gives us our monthly payment. How much do we need to pay every month for this loan? Also, one more thing I'm going to note, when you enter this in your calculator for this negative, you cannot hit the subtraction sign. You need to hit the negative button, which is usually found next to the decimal point on your calculators. So hopefully you have figured that out already, but if not, just make sure when you go to do this negative n, you hit the negative sign, which is not the subtraction sign. It's actually a different button, most likely found next to the decimal point button on your calculator. So let's look at an example. So you are going to borrow $20,000 for a new car. Now this $20,000 would be after any money that you put down. So this is the actual amount of money that you are borrowing for the car. You can select one of the following loans, each requiring regular monthly payments. Installment loan A is a 3-year loan at 7%. Installment loan B is a 5-year loan at 9%. Find the monthly payments and the total interest at loan A, for loan A, of loan A, not at loan A. That's fine. All right, so we are, where's my little thingy-mabob? There we go. Okay, we are borrowing $20,000. So loan A is a 3-year loan at 7%. So P, let's do this, is going to be $20,000. R is going to be 7%, 0.07. N, let's see, they require regular monthly payments. So N is 12. We're going to make these payments 12 times a year. And T, this is a 3-year loan. So using our payment formula, oh, it's already on blue. Our monthly payment, oh, I'm going to need a little bit more room here. Is going to be 20,000 times 0.07 divided by 12 divided by 1 minus 1 plus 0.07 over 12 to the negative 12 times 3 power. And I already have the answer. That gives us a monthly payment of $617.54. You can pause and make sure that you get the same answer before moving on to the next step. So then we also need to find the total interest of loan A. Before we can find the total interest, we need to find the total paid. So to find the total paid, I'm going to take my monthly payment times how many times a year I'm paying this. Oops, general. How many times a year I'm paying this times how many years I'm making these payments for. So in this case, I am paying $617.54. I'm making these payments 12 times every year, and I'm going to make the payments for 3 years. So that gives me a total paid of $22,231.44. You can pause if you need to make sure that you get that same answer. And then our interest. That's found by taking the total paid minus the principal, the amount that we borrowed. Because when we have loans, the interest is any amount in addition to the amount that we borrow that we have to pay for borrowing that money. It's basically, hey, I'm going to let you borrow this $20,000, but I'm not going to let you do it for free. You're going to pay me extra at a rate of 7% for the privilege of being allowed to borrow my money. That's what the bank says. So you pay the bank, or whoever it is that you're borrowing this money from, $22,231.44, but you only needed $20,000 for the car. So that means you paid an additional $2,231.44 in interest. So that's the additional money that you had to pay on top of the loan amount in order to be allowed to borrow the money, essentially. So that's loan A. Loan A comes with a monthly payment of $617.54. You're going to pay a total of $22,231.44, and that's going to be interest of $2,231.44. So let's look at loan B. Loan B is a 5-year loan at 9%. So you have a longer amount of time to pay it off, but they're going to charge you more in interest. So let's see how that affects these values. I'm going to switch just the blue and the purple so that I can tell these apart. So P is still $20,000. We're still borrowing the same amount of money. I'm still looking at the same car. R, now it's a 9% interest rate if I take this loan. It's still monthly payments, but now they're going to give me 5 years to pay this one off. So the payment is $20,000.09 over 12 over 1 minus 1 plus 0.09 over 12 raised to the negative 12 times 5 power, and that gives us a monthly payment of $415.17. So to find the interest, we first need to find the total paid. So the total paid is the monthly payment, $415.17 times 12 times 5, and that's $24,910.20. So then our interest is the difference between how much we paid in total and how much we borrowed. So $4,910.20. So compare the monthly payments and the total interest for the two loans. So the shorter loan term had a lower interest but a higher monthly payment. And that will always be the case. If these two loans had the same interest rate, we would see that the shorter loan term, 3 years, would have a higher payment because we have less time to pay it off, but then we would pay less in interest than if we had the same interest rate but a longer term loan. Now, typically, if they are going to give you more time to pay off the loan, then they're also going to increase the interest rate on you. So the second example is pretty much the same, just different values. So this is a place where I recommend pausing the video, seeing if you can work out all the parts on your own, and then restarting the video to see if you can get the same answers that I do. So I am going to work through this one just a little bit quicker. If you need to go back to the first example to see it worked out a little bit slower, that's what I recommend you do. But just for the sake of trying to keep these videos a little bit shorter, so you are going to borrow $15,000 for a new car. You can select one of the following loans, each requiring regular monthly payments. Loan A is a 4-year loan at 8%. Loan B is a 6-year loan at 10%. So we're going to find the monthly payments and total interest for loan A. It's the same thing that we just did, just different numbers. So P is 15,000, R is 0.08, N is 12, T is 4. I went ahead and turned that percentage into a decimal right away. I didn't even bother writing it down as a percentage. I just turned it into that decimal in my head as I was writing it down. Monthly payments. I'll still write this out. Nope, that's not correct. There we go. Divided by 12 to the negative 12 times 4 power. Monthly payment on loan A is $366.19. Total paid on loan A, $17,577.12. And the interest on loan A is $2577.12. Loan B is very similar, but it's a 6-year loan at 10%. So just writing all of this out again with the new numbers. And the monthly payment here is $277.89. Total paid $277.89 times 12 times 6 years is $20,008.08. So then the interest on this loan is $5,008.08. So comparing the monthly payment and the interest, same as last time. The shorter term loan has a shorter or has a smaller monthly payment and you pay less in interest. Leasing is the practice of paying a specific amount of money over a specified time for the use of a product. It's like a long-term rental agreement. So you're borrowing the car, not borrowing the money to pay for the car. So leasing is kind of like renting an apartment, but for a car. Some advantages to leasing: it requires a small down payment or no down payment. When you buy a car, it'll usually require a little bit more. The lease payments for a new car are lower than loan payments for the same car. So you pay less each month if you choose to lease it than if you decide to buy it. Most people can lease a more expensive car than they would be able to buy. When the lease ends, you return the car to the dealer and you don't have to be concerned about selling the car. You just bring it back. You say, all right, my lease is over. Let's get a new lease going, and you get a new car. Some disadvantages to leasing. When the lease ends, you don't own the car. Most lease agreements have mileage limits, so you aren't allowed to go over a certain mileage during the term of the lease. If you do, then there are penalties you have to pay. So it might be like, you can't drive over 100,000 miles while you are leasing the car. So if you do large amounts of driving, leasing may not be a good option for you. When mileage penalties and other costs at the end of the leasing period are taken into consideration, the total cost of leasing is almost always more expensive than financing a car. It's similar with renting versus buying a house. Okay, it looks appealing to be able to rent an apartment because you don't have all of these upfront costs, but in the end, you almost always end up having to pay more when you rent than when you buy. Same thing with leasing. You have to keep it in perfect condition. Okay, you can't have any scratches, you can't have any dents, you can't have children spilling things all over the interior. It's got to be in absolute perfect condition. Leasing doesn't cover maintenance. You're still responsible for all the maintenance costs, and there are penalties if you end the lease early. I know a lot of people personally in my family who leased for a very long time. And then just in recent years, they have decided not to lease anymore. But it worked for them for a very long time. It just depends on what sort of lifestyle you have. So one more example, just one more bit of practice with that payment formula specifically. So you're looking at two different cars and you've narrowed down the choices to two options. There's a new car that costs $25,000. You can finance it with a 4-year loan at 7.9%. Or there's a 3-year-old model of the same car. It's $14,000. You can get it also for a 4-year loan, but the interest rate is 8.45%. What is the difference in monthly payments between financing the new car and financing the used car? So we're just looking at the monthly payment between the two cars. So let's look at the new car first. The cost of the new car is $25,000. The interest rate on the new car is 7.9%. Turn that into a decimal. It's going to be monthly payments, and it's going to take you 4 years to pay off this car. So the payment for the new car, $25,000 times over 12. I'm going to write this one just a tiny bit differently. Minus 1 plus. Oh, nope, I don't need parentheses there yet. 0.79 over 12 to the negative 12 times 4 power. Okay. So we do this and we get a monthly payment for the new car of $609.15. So let's look at the used car. The used car is $14,000, but it has a higher interest rate, 8.45%. Make sure you keep all the decimals when you are converting interest rates into decimal form. Don't ever round interest rates. Monthly payments and it's also a 4-year loan. So the payment on this one would be $14,000 times 0.0845 over 12. Oop, divided by 1 minus 1 plus 4/5 over 12 to the negative 12 times 4 power. And this monthly payment works out to be $344.75. So the difference in monthly payments the new car has a monthly payment that is $264.40 more for the new car. So is that worth it? That's your call. Is the new car that much nicer and fancier than a 3-year-old model? Probably not, if it's going to save you almost $300 a month. But that's your call to decide. They're your finances. So that is loans specifically applied to car loans, but like I said, this formula for figuring out monthly payments is used to figure out monthly payments on all kinds of loans, not just car loans.